We are talking about analyzing graphs of polynomial functions, and we want to use the x-intercepts to graph the polynomial functions and find turning points, local maximums, and minimums. So in example 2, it asks us to do a number of things. Graph the polynomial function says identify the x-intercepts, the y-intercepts, and points where the local maximums and local minimums occur. Determine the interval at which the function is increasing or decreasing. So that's what we're trying to do. And so we have a list of all of the things that we're trying to calculate. And if we want to find the x-intercepts, we can factor and figure out where that crosses based on that. But we're going to use a graph. We're going to use our graphing calculator in this case. And we have our graphing calculator. And we want to go to y equals. So we hit y equals on our graphing calculator. And I already have the function typed in. So now we can graph it. And then we can see what the graph looks like. And for the x-intercepts, we notice that there is actually only one. And we see it right there. So we can use our calc function. So we can say second calc. And we want to find the 0. So we can hit 0 there. And it says the left bound. So we're going to go to the left. X value needs to be to the left of that. And there we are to the left. Then we need to find the right bound. So we've passed it. Now we're on the right. And then it says guess. So guess where you think it is. I think it's right there. And it tells us that the 0 in this case is negative 3.07. So we'll just 0.74. So negative 3.074, and the y value is 0. Okay, so we found our x-intercept, and we can go ahead and put a sketch where we think that is. So 1, 2, 3, a little bit past 3, so there's going to be our 0 right there. Another point that we can come up with pretty quickly without using the calculator function, we see our y-intercept. In this case, whenever we have a function in standard form that has this constant term over here, this constant term will always be our y-intercept. If we type 0 in, if we plug 0 in for x, that term drops out, that term drops out, that term drops out, and then we're left with the ordered pair 0, 2. So 0, 2, that would be right there. Okay. The next thing that we need to come up with are the local minimums and maximums. And from our graph, we can see that there are two. There's one local maximum and one local minimum. And we can do that using the same calc function. So if we hit second calc, and we want to find, let's say, the maximum first, it's the same process that we've done before. So it says left of where you think the maximum is. So I think the maximum is right there. And so I want to be to the left of that. So scroll over to the left. You can see that arrow pops up. Then it says go to the right, or the right bound. So I'm to the right of it. And then it says guess where you think it is. And I think it's right there. And so we have one maximum. And the coordinate for that is going to be negative 7.21. So that's a local maximum. That's going to be negative 1.721. And then we have the y version is going to be 4.134. And so we can sketch that. So negative 1.7, so negative 1.7, and then we have 4.1. So 4.1 is going to be almost up here. So that's going to be our max, local max up there. And then we can do the same process to calculate our local minimum. And so we can go second calc. In this case, we want to find the local minimum. Then we want to be to the left of it. Then we want to be to the right of it. And then we want to guess where it is. And this one says that our local minimum is going to be 0.387 and 1.792. Okay, so we can graph that point as well. So 0.3 is going to be right there, and 1.79 is going to be a little bit below 2. So we'll be right in that vicinity right there. And we know that this is in odd degrees, so we know that our end behavior is going to go in opposite directions. So we can quickly draw our slope monster face. So we know that this is undefined. We know that this is 0. We know that this is negative and this is positive. And our A value here is positive 0.05. So we know that we're going to be looking at this. So we're going to start low and we're going to work our way high. And we only have one x-intercept. So we're only going to cross the graph once, cross the x-axis once, and then we'll be finishing positive from there. So we're starting low, we're coming up, we're going through the x-intercept up to the local maximum, our turning point. We're going to come through the y-intercept down to the local minimum, another turning point, and then we're going to finish going in that direction. So the last thing that we have to come up with is when it is increasing and decreasing. So we know that as the x value goes to positive infinity, in this case, the y value is also going to positive infinity. As the x value comes from negative infinity, the y value also goes to negative infinity. So we're going to trace our graph as we go from left to right, and we know that it's increasing all the way up till we get to our local maximum. And then it decreases all the way till we get to our local minimum. Okay. The x value here is negative 1.721. And the x value here is 0.387. Okay, so when is it increasing? It starts at negative infinity. So it starts increasing at negative infinity, and it goes all the way till negative 1.712. Or 721. Now, we use parentheses because neither of those points are included. The slope at negative 1.721 is 0, so it's neither increasing nor decreasing. From negative 1.721, it's decreasing all the way till it gets to negative 0.387. So from negative 1.721 all the way until 0.387. 0.387. So that's when it is decreasing. And again, we're going to use parentheses because neither the local max or the local min are included. And then once we get to 0.0387, it turns and starts to increase all the way to positive infinity in the x direction. So then it will start from 0.387 and it'll go all the way to infinity. And if we notice, we're starting at negative infinity, and then we go to negative 1.721. Then we pick it back up at negative 1.721 and go all the way to 0.387. Then we pick it up at 0.387 all the way to positive infinity, and we notice that none of these points are included because we're using parentheses rather than brackets. And then we can just take a look and see what the graph looks like drawn a little bit more accurately. So negative 3.74, then there's the local max, then we have our y-intercept and our local minimum.